Today we're going to finish up this chapter with extraction, rusting and recycling. So what we recall is that reactivity series, the ones that are more reactive, they actually form stable compounds as compared to those that are less reactive. And we also recall that there are two nonmetals, carbon and hydrogen. They are what we will use to determine the extraction method for the metals. The first four metals, from potassium to magnesium, they will actually be above carbon, and as a result they have very strong bonds, and we can only break them down using electricity or in what we call electrolysis. Okay, for those in between carbon and hydrogen, we will reduce using carbon because they are less reactive than carbon, so the carbon will be able to kick out the oxygen, and for those without below hydrogen, they will be reduced with hydrogen instead. For the ones below gold is usually found uncombined. Okay, another thing that we can say about those that are underneath hydrogen, copper, silver and gold, they will also be unreactive with acids. Okay, extraction of iron is a very important part of this chapter. Okay, so iron normally is found in the ground in the form of hematite. And it also, because it's in the ground, there will be impurities such as sand, which is actually silicon dioxide. Yeah, the steps for the blast furnace is very important. You can read this up for yourself, and you just need to memorize the steps, and you need to understand a few things, like for example the carbon monoxide is important because it will be the reducing agent for which you get the pure iron. So in step 3, you will see this is where the pure iron is being formed when the hematite, the iron 3 oxide, is being reduced by the carbon monoxide. Okay, in step 4, the limestone, it serves two purposes. The first one is upon decomposition, it forms carbon dioxide. And this carbon dioxide will go back into step 2 and react with the coke to form carbon monoxide. Same with the carbon dioxide that it actually formed in step 3. But when there's too much carbon dioxide, it will still be released as waste. The calcium oxide from the decomposition of limestone will be used to remove silicon dioxide to form slag, and this slag is collected when it floats on top of the molten iron. Okay, so here we have a simple flow chart to show what happens in the blast furnace and what's being added and what comes out. Okay, and I'll write down the formula for all the things that are being added, such as hematite, limestone. For the air, the main gas that we are looking at is oxygen, because it is the one that will react with the coke to form carbon dioxide. Now it's time to try some questions to apply our knowledge. So for the first question, why is limestone used in the extraction of iron? Okay, so we have a few options here, and we need to recall what are the steps. So when you convert the ore, is the reducing, which is from carbon monoxide. Oxygen is found in the hot air, and to heat the furnace you will just use a fuel. So the most logical answer would be removing acidic impurities, which is silicon dioxide. Okay, for the second question, which one is used in the extraction of metal, we need to follow the reactivity series. Okay, so electrolysis is used for those that are above carbon, and reduction is used for those which are below carbon. So we need to recall the reactivity series, and then you just need to answer which is above and which one is below. Okay, for gold is uncombined, so we'll just use a physical method to extract. What factor determines the method is their reactivity. Rather, we can also say that it is the strength of the bond with the within the ore itself. So the more reactive it is, the okay. For our rusting, there needs two things to take place. Rusting requires water and air, and it's actually a form of corrosion where you'll form a reddish brown substance which is hydrated iron 3 oxide. Okay, so when we have iron in the presence of oxygen and water, we'll get the formula you see below, and the letter X represents the amount of water molecules inside the oxide. So if there's a lot of water, then the X will be bigger. Okay, so this shows that actually there is water within the molecule, but it's not actually bonded, it's just hydrated. Okay, so how do we prove that water and air is required? We have 4 test tubes here. One of the things they have is distilled water. Distilled water means that the water has been boiled and the oxygen is totally removed. Okay, so there's no more oxygen in the water. For test tube B, anhydrous calcium chloride. Anhydrous calcium chloride is a drying agent which will remove all the moisture in the air. For test tube A, you will see oil. The oil will actually be preventing oxygen from entering the water. But for test tube C, the oxygen in the air above the water will actually dissolve inside. Okay. So we have learned before that rust is brittle, okay, which means that it can break easily as compared to metals being malleable. So rusting will actually cause it to break more easily, and this can be quite dangerous if you're using steel in your structure. So it's very important for us to develop means to prevent rusting. So step number 1 is to use a protective layer, which is to prevent air or water from coming into contact. The second one, sacrificial protection, is using a more reactive metal to react in place of the iron, and alloys we have learned before. Okay, the table below shows the advantages or disadvantages of using each of the metal, and you can read this for yourself. For some quick practice, we have an MCQ over here. So what do we need to look out for is an experiment. So we need to make it fair, and we need to keep some of the conditions the same. So for dry air, it is to show that there's no moisture in test tube 1. So we need to use that to prove that water is needed. And then the other one will require water and at the same temperature. So the answer will be B, 1 and 2. Okay, for question 2 is a bit of a hybrid question, which means it includes knowledge from another topic, which is air and atmosphere. So what we learn in air and atmosphere is that oxygen makes up about 21% of the surrounding air. So during rusting, because rusting requires air to be requires oxygen, so 21% of the air inside the test tube will be used up. So we'll get it to a level that is at D. On to the last portion, which is on recycling. Metals are limited and finite, which means eventually they will run out and we won't have any metals left. Okay, so what do we need to do? We need to find ways to conserve it, and one of the way is to find substitutes. So things that we don't need to use metal, we can replace with plastic. And the other way is what we've learned in our environment education, which is to recycle. Okay, so what are the advantages of recycling? I'm sure you are very familiar with all the advantages. Okay, so what we need to look through is we need to look at some of the disadvantages as well. Okay, so some of the disadvantages include actually the fact that recycling might be more expensive as compared to extraction. Okay, so what is the cost involved in recycling? it could be your transportation costs, which includes fuel, collection, and all that kind of thing, and a lot of logistics. So this could make it more expensive than mining metals. Okay. Another thing is that recycling can be actually more harmful. For example, when lead is being recycled, it can produce a lot of harmful gases. Okay, so this summary also shows the advantages and disadvantages of recycling. Okay, so economic issues refer to cost, social issues is habit, and environment issue is for pollution by harmful gases.